Welcome to the deep dive. This is where we take those tech topics you're curious about, maybe even a bit confused by, and pull out the really crucial stuff you need fast.
Yeah, the goal is to cut through the noise.
Exactly. Think of it as, shifting from feeling kind of lost in tech jargon to having those aha moments.
And today we're tackling a really foundational area. We've got this great set of questions and answers you've essentially given us, covering, well, the core of computer technology.
Right. It's like your personalized tech explainer based on what you wanted to know.
Exactly. And it covers a lot of ground. We're talking hardware, the physical bits,
Hmm.
dot networking, how things connect and talk to each other,
Super important.
dot security, obviously crucial,
Definitely.
dot operating systems that run it all, and even some practical troubleshooting for when things inevitably go a bit sideways.
Precisely. So we're not just going to lift facts, we're digging through these Q&As to highlight what really matters, maybe some surprising details, and give you that essential understanding. Okay,
Sounds great?
let's get started then. Let's look under the hood with hardware.
Okay, hardware. So our first question is about storage, specifically in modern laptops. You might wonder what makes some laptops feel so incredibly fast.
Yeah, that instant on field,
Often it's down to the type of SSD connector they use. We're talking MVETA 2 or NVMe.
M.2 or NVMe. Right.
And what's fascinating here isn't just the physical shape. It's about the speed. Think of it like upgrading from a winding country lane that's your older SATA connection to a massive multi-lane superhighway. That's NVMe.
Okay.
This newer interface just lets data move way, way faster.
So that's why your laptop might boot in seconds or open huge files without breaking a sweat.
Exactly. Chances are it's leveraging that NVMe speed. It makes a real difference in how the machine feels to use.
Makes total sense. It's not just a number on a spec sheet. Okay, so how do these parts get their power? We had a question about SATA power connectors and the different voltages, 3.3V, 5V, and 12V. Why all the different levels?
That's a really good question, actually. It digs into how power is managed inside. Basically, different components just have very different energy needs.
Oh, okay.
Some tiny chips might only need a SIP, like 3.3 volts, but more power-hungry things, like, say, some drives or older graphics cards, they need the full 12 volts.
And the 5V?
The 5E kind of sits in the middle, powering various other circuits and peripherals. It's all about efficiency, giving each part exactly what it needs, no more, no less. Pretty sophisticated, really.
Like a finely tuned electrical grid inside the box. Got it. Now, what about that very first moment when you hit the power button? There's a question here about POST. What's actually happening then?
Right, POST. It stands for Power On Self-Test. Think of it like your computer doing a quick check of its vital signs before it properly wakes up.
Like a morning stretch.
Sort of. It checks the essentials, CPU, memory, graphics card, making sure they're there and responding. It's a crucial first step.
And if it finds a problem,
Then you might get those infamous beep codes, or maybe an error message. It's basically a pre-flight check for your PC before the main operating system even tries to load.
pre-flight check, I like that. And if you suspect the power itself is the issue, like nothing's happening at all, what tool do you use?
Yeah, the question mentions a power supply tester or a multimeter. These are key for diagnosing power issues.
How do they help?
Well, a power supply tester is purpose-built. You plug it into your PSU connectors, and it tells you if the right voltages are coming out. Quick and easy.
Okay.
A multimeter is more versatile. You can measure voltages manually, get more detail maybe. Both help you figure out if the PSU is healthy or if it's the reason your computer's playing dead.
Like a checkup for the power supply. All right, power's good, POT passes. What about RAM? The question mentions DDR4 or DDR5 as common types. Now, what's the real difference for, the average person?
Good question. DDR4 and DDR5 are different generations of memory tech. Each new generation generally gets faster and offers more bandwidth.
Bandwidth, like a wider pipe for data.
Exactly like that. More bandwidth means more data can flow through simultaneously. So for you, this means your system feels snappier overall. Multitasking is smoother, big files load faster, games run better.
And DDR5 is the newer one.
Right. DDR5 pushes that speed and efficiency even further than DDR4. It's the latest standard.
Faster pipe, smoother experience. Got it. Okay, let's switch to getting stuff out of the computer. Printers. Laser printers use toner, the question notes. How's that different in practice from an inkjet?
Yeah, the core difference is the material. Laser printers use a fine powder, toner, which gets melted onto the paper with heat.
Okay.
Inkjets, well, they spray tiny drops of liquid ink.
And that affects what they're good at.
Definitely. Lasers are typically faster for text documents, lots of pages, and often cheaper per page for black and white.
Right, office workhorses.
Pretty much. Inkjets tend to be better for high-quality color photos and images, so what you print most often usually guides the best choice.
Speed and economy versus vibrant color. Makes sense. Now, connecting devices together, the question mentions a network hub, saying it doesn't manage traffic. What's the downside of that?
Hubs. They're quite basic, kind of old tech now, actually. When a hub gets data on one port, it just blasts it out to every other port.
Oh, wow. No direction.
None at all. It's like shouting in a crowded room, creates a lot of noise, collisions, slows everything down. That's why they've been largely replaced by switches. We'll probably touch on those later.
Okay, so inefficient shouting versus something smarter. Got it. Back inside the PC, there's a question about the PCIe X16 slot, often used for graphics cards, right? Why that specific slot?
Yes, exactly. The PCIe X16 slot is basically a high-speed data lane designed specifically for things that need massive bandwidth, like modern graphics cards, GPUs.
Why so much bandwidth needed?
While rendering complex 3D graphics for games or processing video, it involves moving huge amounts of data very, very quickly between the card and the rest of the system. The X16 means it has 16 lanes for data, a really wide highway.
A dedicated superhighway for graphics. Cool. Here's a quick visual one. USB 3.0 ports, they're often blue, the question says. Why?
Yeah, that blue color is a common visual cue. It's not a perfectly enforced standard, but many manufacturers use blue to help you quickly spot the faster USB 3.0 ports.
Oh, so you know where to plug in your fast external drive.
Exactly. You want to make sure you're using the faster port to get the best speeds. It's just a handy little identifier.
Simple but useful. Okay, last hardware question. RAID 1. What does it do and why should someone care about it for their data?
RAID 1 is all about something called mirroring. And the key concept here is data redundancy.
Redundancy, like a backup.
Essentially, yes. In a RAID 1 setup, you have two drives, and your data is written to both drives simultaneously, creating an exact mirror image in real time.
So if one drive fails,
The other one just keeps running with all your data intact. You don't lose anything. It's like having an instant automatic backup against hard drive failure. Huge peace of mind for important files.
a safety net for your digital stuff. Makes sense. Okay, let's shift gears. How do these machines talk to each other? Let's get into networking. First up, DHCP. What is it and why is it useful?
DHCP, Dynamic Host Configuration Protocol. It's kind of the unsung hero of easy network connections.
How so?
It automatically assigns IP addresses to devices when they join a network. Imagine walking into an office, and instead of having to find and assign yourself a phone extension, the operator just gives you one automatically. That's DHCP for your computer's network address.
So when I connect my phone to Wi-Fi, DHCP is handling that IP address assignment.
Yep, it assigns the IP, the subnet mask, the gateway, all the necessary info so you can just connect without manually configuring things. Makes life much simpler.
Definitely sounds easier. Next, wireless standards. The question mentions 802.11ac, which is often called Wi-Fi 5, and its successor .ax is Wi-Fi 6. They operate on both 2.4 gigahertz and 5 gigahertz bands. What's the benefit of that dual band thing?
Right, that dual band capability is really clever. Think of it as having two different types of radio highways available.
Okay.
The 2.4 gigahertz band travels further and goes through walls better, but it's often more crowded and slower, like local roads with lots of traffic and interference from microwaves, Bluetooth, etc.
Gotcha.
The 5 gigahertz band is much faster and less congested, like an express lane, but its range is shorter and it doesn't penetrate obstacles as well.
So having both lets your device choose the best lane.
Exactly. Your router and device can pick the best band based on signal strength and interference, giving you a more stable and potentially faster connection.
Smart traffic management for Wi-Fi. Okay, a basic security concept. The firewall, what's its main job?
A firewall acts like a security guard for your network's front door. Its fundamental purpose is to monitor network traffic, both coming in and going out, and decide whether to block it or allow it through based on a set of security rules.
So it filters out the bad stuff.
Pretty much. It helps prevent unauthorized access, blocks potential threats from the internet, and generally shields your devices and data from malicious activity. It's a critical layer of defense.
A digital gatekeeper. Makes sense. Now, if you're having trouble with wired connections like your Ethernet cable, the question mentions a cable tester. What does that actually check?
A cable tester is a simple but super useful tool. It basically checks the physical integrity of your network cable.
Like if the wire's broken?
Yeah, it sends signals down each wire pair in the cable to see if they're connected correctly end to end, if there are any breaks, or if wires are shorted together. A bad cable is a surprisingly common problem, so this tool helps you quickly confirm or rule that out.
Checks the physical path. Got it. Here's a more technical one. The loopback IP address, 127.0.0.1. What's that for?
The loopback address. It's a special address that basically means this computer itself.
Talking to yourself.
Kind of. It lets your computer send network traffic to itself. Its main use is for testing. If you're developing a network application or setting up a server on your own machine, you can use 127.0.0.1 to test if it's working locally before exposing it to the actual network.
So it's an internal check.
Exactly. If you can ping 127.0.0.1 successfully, It usually means the basic networking software on your computer is up and running correctly.
Handy internal diagnostic. Okay, so browsing the web, we see HTTP and HTTPS. Port 80 for HTTP, port 443 for HTTPS. What's the crucial difference we should know?
The difference is all about security. HTTP sends data in plain text,
Like a postcard.
exactly like a postcard. Anyone intercepting it could potentially read it. HTTPS, the S stands for secure, uses encryption.
So it scrambles the data.
Right. It scrambles the data between your browser and the website's server, so even if someone intercepts it, they can't read it. This is vital for anything sensitive logins, credit cards, personal info. You usually see a padlock icon in your browser for HTTPS.
Look for the lock. Good tip. We mentioned hubs earlier being dumb. What about switches and routers? How are they different?
Okay, good distinction to make. A switch is smarter than a hub. It connects devices within the same local network, like your home network.
And it directs traffic.
Yes. Unlike a hub blasting everything everywhere, a switch learns which device is connected to which port and sends data only where it needs to go. Much more efficient for your local traffic.
Okay, so switches for local efficiency. What about the router?
The router's job is to connect different networks together. The most common example is connecting your entire home network, your LAN, to the internet, the WAN wide area network. It figures out the best path for data to travel between networks.
So switch manages the house, router connects the house to the world.
That's a great way to put it.
Next up, IP address. What does it fundamentally tell us?
An IP address is essentially a unique numerical label, like a postal address, for a device on a network.
Unique on that network.
Yes, within a specific network, each device needs a unique IP address so that data packets know where to go. It allows devices to find and communicate with each other. You have private IPs on your local network and usually share a public IP when accessing the internet.
Your device's network address. Got it. Finally, for networking, how do we get from easy website names like google.com to those numerical IP addresses computers use? That's DNS, right?
Exactly. DNS, the domain name system, is often called the internet's phone book.
Phone book.
Yeah, its job is to translate the human-friendly domain names we type into browsers into the numerical IP addresses that computers actually need to locate the server hosting that website. Without DNS, we'd have to memorize strings of numbers.
Thank goodness for DNS then. Okay, that covers networking basics. Let's pivot to keeping all this activity safe. Security. First concept. BIOS. What is it and what does it do right at startup?
BIOS Basic Input-Output System. It's firmware, like low-level software, stored in a chip on your motherboard. It's literally the very first thing that runs when you power on your computer.
Before Windows or anything else?
Absolutely. Its job is to wake up and test the fundamental hardware CPU, RAM, drives, basic checks. Once it confirms the essentials are okay, then it hands off control to your operating system to start the main boot process.
The foundational wake-up call. Got it. Now, a big one these days, two-factor authentication, or 2FA. What is it, really, and why is it so important?
2FA adds a second layer of security beyond just your password. It requires you to provide two different types of proof of identity.
Like what?
Usually it's something you know your password, plus something you have, like a code from an app on your phone or SMS text, or something you are, like a fingerprint or face scan.
So even if someone steals my password,
They still can't get in without that second factor. It makes it significantly harder for hackers to compromise your accounts, a really crucial defense.
that extra step makes a big difference. Security isn't just tech, though. The question mentions social engineering. What's that about?
You're right, it's about the human element. Social engineering is basically manipulating people to get them to reveal sensitive information or perform actions they shouldn't.
Like tricking them.
Exactly. Think phishing emails that look legitimate but steal your login, or phone calls pretending to be tech support to get remote access. They exploit trust and psychology, not just software flaws. Awareness is key here.
The human firewall needs to be strong, too. So for something portable like a laptop, what are some key physical and digital security steps?
Yeah, the question highlights two good ones, a cable lock and a strong password.
Cable lock for physical security.
Right, you loop it around a desk leg or something fixed, making it harder for someone to just walk off with your laptop in a cafe or library. Physical deterrent.
And the strong password for the digital side.
Exactly. Protects your actual data and accounts if someone does get physical access or tries to guess their way in online. Combining both is essential for laptops.
Layered protection. Makes sense. Now, for nasty software, what's a rootkit? Sounds ominous.
They are pretty ominous. A rootkit is a type of malware designed specifically to hide its own presence, and often other malware too, deep within your system.
Hiding. How?
By embedding itself at a very low level, sometimes even modifying parts of the operating system, it can become invisible to regular antivirus scans and system tools. This makes them incredibly difficult to detect and remove.
Stealthy and dangerous. Got it. For protecting the data on the drive, especially in Windows, the question mentions BitLocker. What does that do?
BitLocker is Microsoft's tool for full disk encryption. When you enable it, it scrambles all the data on your entire hard drive, or SSD,
Scrambles it how?
using strong encryption algorithms. The only way to unscramble it and read the data is with the correct key, which is usually tied to your Windows login password or a special recovery key you need to keep safe.
So if someone steals the laptop,
They can pull out the drive, but without the key, the data is just unreadable gibberish. It protects your data at rest when the computer is off or locked. Very important for privacy and security.
digital safer files, good analogy. For securing home Wi-Fi, what's the best standard to use now?
The question points to WPA3, and that's correct. It's the current most secure wireless encryption standard that's widely available.
Better than the older WPA2.
Yes, it offers stronger encryption and better protection against certain kinds of attacks compared to WPA2. If your router and your devices both support WPA3, definitely use it. Check your router settings.
Aim for WPA3 if possible. Okay, antivirus software, most people have heard of it. What's its basic function?
Antivirus is your primary defense against known malware viruses, worms, trojans, ransomware, spyware, all that stuff.
How does it work?
It typically scans files as you access them and monitors system activity, looking for patterns or behaviors that match known threats in its database. When it finds something suspicious, it tries to block, quarantine, or remove it.
And keeping it updated is key.
Absolutely crucial. New threats emerge constantly, so your antivirus needs the latest updates to recognize and fight them off effectively. It's like your system's immune system.
Digital immune system, nice. The question asks for an example of a strong password and why complexity matters so much.
Okay, a strong password example might be something like transvora for door in 3. The key, as the question implies, is complexity and length.
What makes it complex?
Using a mix of uppercase letters, lowercase letters, numbers, and symbols. The more variety and the longer it is, the exponentially harder it becomes for criminals to crack using automated guessing tools like brute force attacks. Randomness is your friend here. Avoid dictionary words or personal info.
Mix it up, make it long and random. Got it. Last security point, BIOS password. What does that protect?
A BIOS password adds a layer of security right at the hardware level, even before the operating system starts loading.
Wow.
If you set one, you have to enter that password just to get the computer to boot up past the initial BIOS screen. It can prevent someone from starting your computer at all and also stop them from changing critical BIOS settings like the boot order without permission.
An extra lock right at the beginning. Okay, that wraps up security. Let's move to the software that pulls it all together. Operating systems. We're focusing mainly on Windows. Why is it so dominant in business?
Well, historically, Windows gained a huge foothold in business for a few reasons. Compatibility is a big one, vast support for hardware, and tons of business-focused software applications.
Familiarity too, I guess.
Definitely. Many companies built their IT infrastructure around Windows tools for managing networks, users, security policies. It became the standard, though other OSs are certainly used too, especially in specific niches.
The established player. Okay, when your PC feels slow or weird, Task Manager is often the first stop. What does it show you?
Task Manager is like your computer's dashboard. It gives you a real-time look at what's running all the apps, all the background processes.
And performance stats.
Yep. Crucially, it shows how much CPU, memory, disk, and network each process is using. It's invaluable for spotting resource hogs that might be slowing things down, or for killing applications that have frozen up, a key troubleshooting tool.
A peek under the hood at resource usage. For managing the storage itself, there's disk management. What can you do there?
Disk management is the Windows tool for controlling your hard drives and SSDs. You can see all your connected drives and the partitions on them.
Partitions, like dividing up the drive.
Exactly. You can create new partitions, format them with a file system like NTFS, assign drive letters so you can see them in File Explorer, and even resize partitions, so you need to be careful doing that. It's for organizing your storage space.
Organizing the digital closet. If you think there might be errors on the drive, the question mentions KT-skip. What's that?
KT-skept, or check disk, is a command line tool. You want it to scan a drive partition for errors in its file system structure.
File system errors, like what?
Things like corrupted file records, indexes that don't point correctly, stuff that can cause instability, data loss, or even prevent Windows from starting. ChGD's Code tries to find and fix these logical errors on the disk.
A repair tool for the drive's organization. Got it. We often see NTFS and FAT32 mentioned as file systems. What's the main difference for users?
The biggest practical differences are file size limits and features. FAT32 is older, it can't handle individual files larger than 4 GB, and its partition size limits are smaller too.
4 GB. That's not much these days.
Right. NTFS is the modern standard for Windows. It supports much larger files and partitions, and crucially, it has better security features like file commissions, allowing you to control who can access what. Plus, it's generally more robust and recoverable.
So NTFS is generally better for modern use.
For Windows systems, absolutely. FAT32 is mainly used for compatibility with older systems or some external devices like USB drives sometimes.
Okay, NTFS for the win, usually. When Windows has trouble starting, safe mode is often recommended. What does booting into safe mode actually do?
Safe mode starts Windows using only the absolute bare minimum set of drivers and services needed to function.
Strips it down.
Exactly. It doesn't load most third-party drivers, startup programs, or non-essential Windows features. The idea is, if your computer works fine in safe mode, the problem is likely being caused by one of the things that isn't loaded in safe mode, like a bad driver or a conflicting program. Helps you narrow down the cause.
A diagnostic boot environment. Makes sense. Another key tool, Device Manager. How do you get to it and what does it show?
Easiest way is usually right-clicking the Start button and choosing Device Manager. It lists all the hardware components recognized by your computer.
Everything. Graphics, network, sound.
Yep, all categorized. You can see if devices are working properly, check their drivers, update drivers, disable devices. It's the central place for managing hardware and troubleshooting driver issues. That yellow exclamation mark we might discuss later often shows up here.
The Hardware Control Center. Got it. Keeping Windows Update. What's its main job?
Windows Update's main purpose is to download and install updates for Windows itself and other Microsoft products. These updates are vital.
Why vital?
They deliver security patches to fix vulnerabilities that malware could exploit. They fix bugs that cause crashes or instability. And sometimes they add new features or improve performance. Keeping updated is one of the most important things you can do for security and stability.
Stay current, stay safe, and stable. The question mentions imsconfig. What's that utility used for?
imsconfig, or system configuration, is a tool for managing how Windows starts up. You can control which programs and services launch automatically at boot.
Useful for speeding up startup.
Definitely. If your computer takes ages to boot, you can use imsconfig to disable unnecessary startup items. It also gives you access to advanced boot options, like starting in safe mode. It's more for tweaking the startup process.
Fine-tuning the boot sequence. Okay. And finally for OS, diagnose and network issues. What info does the ipconfig command give you?
ipconfig is a command line tool that shows your computer's current network configuration settings.
Like your IP address.
Exactly. It shows your IP address, the subnet mask, the default gateway, usually your router's address, and the DNS servers your computer is using. Essential info for troubleshooting if you can't connect to the network or the internet.
Your network identity card, basically. Okay, that covers the OS basics. Let's move into practical problem solving, troubleshooting, and scenarios. Scenario 1, PC won't power on at all. Dead silence. What's the very first thing to check?
Before you panic, check the absolute basics. The power cable. Is it securely plugged into the computer and the wall outlet? Sounds simple, but it's common for them to get loose.
Try a different outlet, too.
Good idea. Rule out the outlet itself. If it's still dead, then you start thinking about the power supply unit inside the PC as the next likely culprit. But always check the cable first.
Check the plug. Right. Okay, next scenario. Your printer starts printing gibberish, just random characters. What's likely going on?
That usually points to a printer driver issue. The driver is the software that lets your computer talk properly to your specific printer model.
So they're not communicating correctly.
Exactly. The driver might be corrupted, outdated, or just the wrong one. The fix is usually to go to the printer manufacturer's website, download the latest correct driver for your operating system, and reinstall it.
Update or reinstall the driver. Got it. Scenario 3. Annoying Wi-Fi keeps disconnecting. What should you investigate first?
Frequent Wi-Fi drops often come down to two main things: signal interference or channel congestion.
Interference from.
Other devices using the same 2.4 gigahertz frequency microwaves, older cordless phones, Bluetooth devices, even neighboring Wi-Fi networks. Physical obstructions like thick walls also interfere.
And channel congestion.
Your router broadcasts on a specific channel within the Wi-Fi band. If many nearby networks are using the same channel, it gets crowded. Log into your router settings and try changing the Wi-Fi channel to a less congested one. Sometimes that helps a lot. Find a clear channel. Okay, scenario 4. Your PC keeps restarting randomly out of the blue. What could cause that? Sounds serious. It can be serious, often indicating a hardware issue. Key suspects are faulty RAM, the system overheating, or a failing power supply.
How do you check those?
You'd use tools like Windows Memory Diagnostic or MemTest86 to test the RAM. Monitor your system temperatures using software to see if it's getting too hot, maybe dust is clogging the fans. And a PSU tester or trying a known good PFU can check the power supply. Requires some investigation.
RAM, heat, or power. Needs diagnosis. Okay, the dreaded BSOD. What does it stand for and what does it mean?
BSOD is the blue screen of death. It's what Windows displays when it hits a critical error it can't recover from.
A fatal error.
Essentially, yes, the system holds to prevent further damage and shows the blue screen with some error codes. It usually indicates a major problem with hardware, like failing RAM or a bad hard drive, or a critical software issue. often a faulty driver. It's a sign something is seriously wrong.
Not a good sign. Back in Device Manager, sometimes you see a yellow exclamation mark next to a device. What does that mean?
That yellow exclamation mark is a flag. It usually means Windows has detected a problem with that specific piece of hardware.
What kind of problem?
Most often, it's a driver issue. The driver might be missing, corrupted, incompatible, or just not working right. Less commonly, it could indicate a hardware conflict or that the device itself is malfunctioning. Updating or reinstalling the driver is the first thing to try.
Yellow mark equals driver check first. Got it. We mentioned tools for testing RAM earlier. What were they again?
The main ones are the built-in Windows Memory Diagnostic tool and a popular, more thorough third-party tool called MemTest86. You usually run MemTest86 from a bootable USB drive before Windows loads. Both stress test your RAM modules to find errors.
Specific tools for RAM health checks. Okay, shifting to the process itself. What's the absolute first step in any troubleshooting situation?
The most crucial first step is always to clearly identify the problem. What exactly is happening? When did it start? Does it happen every time? Are there error messages? Gather as much specific information as possible before you start trying fixes.
Define the problem clearly. Makes sense. And what about the last step, after you've fixed it, or even if you haven't?
The often skipped but really important last step is documentation. Write down what the problem was, what steps you took to diagnose it, what worked, what didn't, and what the final resolution was.
Why is that so important, especially, say, in IT support?
Oh, it's vital in IT. That documentation builds a knowledge base. If the same problem happens again or to someone else, that record saves huge amounts of time. It ensures consistency, helps train new people, identifies recurring issues, and provides an audit trail. It's fundamental for efficient support.
Builds collective knowledge, ensures consistency. Got it. Well, that brings us to the end of this particular deep dive. Wow, we covered a lot of ground.
We really did, from hardware components, networking principles, security layers, operating system functions, right through to practical troubleshooting steps.
Hopefully, this overview gives you a much more solid footing, a better handle on these core tech concepts without feeling, totally swamped.
Absolutely. The goal is to pull out the essentials, make it accessible, help you feel more informed.
So, here's a final thought to chew on. We've seen how interconnected all these areas are. Hardware needs software, networks need security, OS manages hardware. Considering all that, what single area do you now think is maybe the most critical linchpin for keeping your own computing experience reliable and secure? Just something to ponder.
That's a great question. And, we're always interested in what you want to explore next. Are there other tech areas, specific gabbits, software mysteries you'd like us to dig into for a future deep dive? Let us know.